8.2 and 8.3, for some reason that I don't remember, I have put together into one lesson. They can easily be taught in a period of time. They're not so closely related that they should really be in the same lesson, but nevertheless, they are. The first 6 questions actually come from 8.2, and then you'll see a dramatic change in the lesson. All of the questions from 8.2 really deal with function notation a little bit more. So let's remember what we have already talked about with function notation. If you have f of 2 equals 7. We looked at function notation yesterday. That means that when the function, some equation involving x, when the function is evaluated at the value 2, you get the value 7. When you plug 2 in, you get 7 back out. What would that translate to as far as an ordered pair? What's the x and what's the y? 2 is the x, 7 is the y. So always, always in function notation, the number here is the x, the value that you get is the y. Now, we're going to spend a little time looking at how that shows up graphically. The first question says, and I will enlarge this for those of you in the room, it says, use the graph of the given function f of x to find the value f of 1. Okay, you are given f of 1, you're given the 1, and you're asked to find out what it's equal to. Now, what you need to ask yourself is, are you given the x or the y of the point? X. Do you agree that you are given x? All right, x is 1. Look on the graph. Find the location where x is 1. Now, maybe it's very easy to find because it's a highlighted point. But if it weren't highlighted, what you would do is say, well, let's see, x is 1. X is 1 here. Whoops. X is 1 all along here. X is 1 all along here. Do y'all agree that everything on that not so straight yellow line is x equals 1? Where did that hit your line? It hit it right there. That's kind of ugly. All right, it hit it right there. What is that name of that point? It is 1 comma negative 5. So how will you answer the question? F of 1 is equal to negative 5. They gave you the x, they want to know the y. Now it's easy, pretty easy, because they put the dot there. If they hadn't, then you would have said, well, let me see where x equals 1 hits my blue line. And it hit it right there. You name the ordered pair, you answer the question. All right, let's look at another one.
So wherever the blue line hits is where?
Yes, is the point in question.
So the 5 be the y value?
Yeah, the negative 5 is the y value. All right, number 2. Use the graph of the given function to find a value. And it wants us, it's telling you f of negative 1 is something. Well, what were you given? You were given x. You're looking for the y. Now, once again, the point is bold. But if it weren't, you would say, well, let's see, x is negative 1. X is negative 1 here and all along here. That is the line, x equals negative 1. Where did it hit my blue line. It hit it right there. And what is that ordered pair? Negative 1, comma 2. So f of negative 1 is 2. They gave you the x. They want to know the y that goes with it. We're just using function notation. This question could have been, and I'm going to erase this after I write it, but this question could have been, complete the t-chart. X is negative 1, what's y? You still would have gone and looked for that point. It was written in function notation instead, though. Number 3. It says, use the graph of the function to find x such that f of x is equal to negative 2. Now this time, what did they give you? They gave you the y. They want to know what the x is. All right? Now, once again, the point is highlighted for you, but if it weren't, you would say, well, let's see. Y is negative 2 right here and all along here and all along here. And where does that cross my line? Right there. What are the coordinates of that point? For those of you who can see it very easily, it's negative 1, negative 2. So the answer to the question is x equals negative 1. So this time you were given a y and you were asked to find the x.
It don't look like it's close to 1, it looks like it's closer to 0.
Well, the 0 is right here. So it is one block to the left.
You're not close to x. I'm saying the negative 2.
Okay, but the x, look at the x value. If this is the point, the y value is negative 2. The x value came from negative 1. See, this is 0, and this is negative 1 right here.
Oh, to the closest to it.
Uh-huh.
Oh, okay.
All right. Let's look at the next ones. In this, we're not going to have a dot. So we're going to have to know more. And honestly, I think question number 4, I think the graph is just a little bit off. But, you know, you're used to that. You look at my graphs all the time. It says, and the reading is hard to see, it says use the graph of the function to write the corresponding ordered pair if f of something equals 8. At least that's what it looks like to me. All right. What did they give you? They gave you a y. They said y is 8. Well, where is y8 on the graph? Do you agree that y is 8 right here? Mm-hmm. And my line is kind of bold, but that's where y is 8. Where is the point where it touches your funny U shape? Well, it seems to be touching it up there. To me, that looks just a teeny bit to the left of 1, but it is supposed to be at 1. So that would be the point. What would that be the point if you said that it is, the x is 1? It would be 1 comma 8. To me, it kind of looks like 3/4 comma 8, but it's not. We'll just say it's 1 comma 8. So the answer to your question is type an ordered pair. It doesn't want just the x. It wants ordered pair 1 comma 8 with the parentheses. Mm-hmm. It has. It depends on the instructions, whether you put in parentheses or you don't put parentheses. If I understand your question correctly, if it ever says type an ordered pair, then you need parentheses. it might just ask for a listing of things, and then you would not. And in this one, you do. So you do have to watch out for that. Question number 5. It says use the graph of the function to find f of 3. Well, it's nice. It gave you a point, but f of 3 equals something. What were you given? You were given x is 3. All right, x is 3 along here. Where does that cross your graph? At 3, negative 6. Now, some of the questions just said, what is this one is one of those. It just wants the value that you would plug in right here. It didn't say it wanted an ordered pair. So all it wants is negative 6. So you've got,
We wouldn't put y equals -6.
no, it already has f of 3 equals. Okay, so it's already started it for you. Only write the entire ordered pair if the instructions say to. And if you're ever unsure about the format of an answer, what does it really want? Go ahead and click on that thing that says show me an example and look at the final form of the answer.
Why would that part be a positive 6 when 6 is on the right side, the dot?
Because it is down. It is a positive 3 in the x direction, but it's down 6, and so that's why it's a negative 6.
Okay, so it would be above the arrow, then it'd be positive.
Yes, yes. So for x's, left is negative, but for y's, down is negative. Question number 6. We're supposed to use the graph of the function to find all values. That kind of makes it sound plural. All values of x such that f of x equals 1. Well, what were you given? What is the y? I'm sorry. What was the 1? It was y. All right, answer my own question. So y is 1. Well, where is y 1? It is right there and all the way across. And for some reason, when I do that, it's really, really bold. Well, how many places did it hit my graph? 2, but that doesn't surprise us because of the way the question was phrased. Y is 1 there, and y is 1 there. Okay? For this one, the y is 1. What's the x? It is 5, 1. That's that point. What about this point? It is negative 1, 1. So there are 2 places where y is 1. What does the question say? Find all the x's. Use a comma to separate your answers as needed. X equals. What does x equal? Negative 1, 5. That is not an ordered pair. That is a list of x's. So you might be thinking and processing the same thing but answering the question differently. So you have to really read your instructions. If these had been separated, that would have been lesson 8.2. All it was really about was more with function notation and how it relates to the graph. And that'll be important to you a little bit in college algebra. Moving on now, almost seamlessly, to 8.3, there is some information that I'd like you to remember. I would like you to commit to memory. Some of it I have written on here, and then I'm going to add one at the bottom. All right. You know what? If I said, what does y equals mx plus b look like? It looks like what? What's the shape of any graph? Oh, of any graph that is y equals mx plus b, what's it going to look like? There's going to be a slope, but how would you describe what I draw? A line. Yes, it's going to be a slanted line. All right, it will look like a slanted line. You know that already. If you have a function that is of this form, f of x, and it could say y, equals x squared. It's called a squaring function. What does it look like? This is what I'm going to ask you to memorize. And it's not hard. It looks like what's a little bit of a U shape. Now, mine are never perfect. It's supposed to be a symmetrical shape. This little right-hand branch is supposed to be exactly like this left-hand branch. They're supposed to be equidistant away from the y-axis, but mine hardly ever is. Sometimes people call it, oh, it looks like a U. Well, sort of does. It continues to widen as it goes up. Its minimum point is sitting right here at the origin. Question?
So if it's a positive, it goes up, and if it's a negative, it goes down?
Yes, it does. We're actually not going to look at the kind that go down in this class, but you're right.
Oh, so that's not there for anything like that.
Oh, okay. It's a distracting choice, but it's not the right answer. Okay, so when you wake up tomorrow, I want you to know that the squaring function, that f of x equals x squared, looks like this. It looks like the U. Okay? Another one that I want you to recognize is f of x equals the absolute value of x. Now, if we had lots of time, what I would be doing is building t-charts so that we would actually create these graphs. But we don't have a whole lot of time, so instead I'm asking you to take my word for it. And if you don't believe me, I'll be glad to stay after class and we'll create a t-chart together. All right, what this one looks like, it looks like a V. If you were to find several ordered pairs, plugging in some x's and cranking out their y's, you would get points that go on this right-hand side and points that go on this left-hand side, and you would get 0, 0. So you get a V. Absolute value graph looks like a V. All right, the third one is the square root function. The square root function looks like a little branch that rises in the upper right-hand quadrant, in quadrant 1. The reason it abruptly starts right here at the origin is, are you allowed to plug in negative numbers and take square roots of negative numbers? You may not be all that familiar with it, but the answer is no. You don't take square roots of negative numbers. So it doesn't ever go further to the left. It just goes to the right. Okay? So far, the squaring function is the U. The absolute value function is the V. The square root function is the little branch. Those are the three that you're going to see in my math lab. There is a fourth one that you're going to see on your test. So I want to make sure that you're comfortable with it. It is f of x is equal to x cubed, the cubing function. This one will not show up in math lab, but will show up on your test. It looks like a rising function that wiggles through the x-axis and then wiggles on the other side. Mine is a little bit exaggerated, but it wiggles through right there at the origin. And sometimes I call it the wiggle. So you have a wiggle. For the square root, you have a branch. For the absolute value, you have a v. And for the squaring function, you have a u. Now, although this is an online test, which means if I were getting ready for an online test, my instructor knows it's online. She knows I'm going to use everything I can get my hands on. So I would have this organized set of notes. I would have my review. I would be ready with everything I might possibly need. So you could have this page sitting there, and that would be fine. But do keep in mind that you have to take a final exam in this class that is comprehensive, that does not allow you to have these out. So you'll want to know what the shapes are. All right, now, how am I going to use this? If I continue on, I want to talk about, with any function, but these are the four I'm going to use. With any function, I want to talk about the concept of transformation. Transformation. To transform something is to change it. But I'm hoping that if we do certain things that we're going to predict what the change will be. All right, I'm going to write down some things at first that you might be a little confused about, but if you will, go ahead and take the notes, and then I'll do the discussion. Suppose that you are given y equals some function of x. Now, what could it be? It could be y equals x squared. It could be y equals the square root of x, absolute value. It could be anything. It is a function of x. And let's say you know what its graph looks like. If you then transform that function by adding a constant to it, add a 2, add a 7, add a 9, add something to it, what's going to happen is that it is going to shift up C units. It's going to maintain its exact shape, but it's going to be shifted up. I promise examples to come. All right, suppose that you instead have that same function, the squaring function, the square root function, absolute value function, and instead you subtract a number from it. Well, what does your common sense tell you is going to happen? It's going to shift down. It's going to shift down C units. It's going to maintain the shape. It's just going to be like somebody grabbed it and pulled it down, so many units. Now the next two, and there are only 4 transformations that we look at in this course. There are other transformations. What if I have y equals f of x plus c? And right now, all you really notice is that I put the plus c in the parentheses instead of outside the parentheses. That would be like putting a number inside parentheses and saying y equals parentheses x plus 2 and then square it. It's putting the number in before the function takes place. Bear with me. I know it's hard to visualize right now, but it will make more sense in just a minute. If you do that, it has a result that most people don't predict. It will shift horizontally. You might have expected that, but it will shift to the left C units. Now, most people say that doesn't make any sense. It's got a plus sign, and plus shouldn't go to the left, but it does. So when you add a quantity inside, before the function gets to act on it, it shifts horizontally the opposite of what the sign says. All right, the last one, y equals f of x minus c. Well, you tell me, what's it going to do? It's going to shift right c units. Yes. All right, now, what am I talking about when I keep talking about these are outside and these are inside? Okay, let me give you one example before we go to the notes, to the actual problems. What if I said, let me scoot this. To sketch, that means it doesn't have to be perfect, to sketch y equals x squared plus 2. And I'm going to change something. If you're taking notes in ink, you'll be angry with me. Instead of y, all of the problems in this lesson will use the function notation, so it will say f of x. Well, do you know what f of x equals x squared looks like? It's a u. Well, I'll just go ahead and just draw it solid. Okay, it's a u. I have added 2, and it is after, outside the squaring. So what will the graph of x squared plus 2 look like? Up to. It says to go up to. So the graph would look like somebody grabbed my u and simply moved it up 2 units. What if I said, would you sketch f of x is equal to x squared minus 3? It will pull it down. It's still the squaring function, but it will go down 3 units. So 1, 2, 3, and I'll draw my u down here. So there's a change, there's a transformation, but we know what to expect. Now, how about those horizontal ones? Well, if I want you to do a horizontal shift, then what I do is put the squaring function in parentheses, and what if I said x plus 2 squared? Do you see that that plus 2 is inside the parentheses? And if I said, oh, let x be 1, think about what you would do. You would put 1 in there. Would you add 2 to it and then square, or would you square first? Wouldn't you add 1 to it because it's in parentheses? When it's in parentheses and it's going to get the number before the function acts on it, it has the horizontal shift. So this will shift, y'all tell me, to the left 2. Remember, these tend to go in the reverse of what their sign says. So this one would look like this. It's still a u, but somebody pulled it to the left. And last one, before we look at our problems, if I have f of x is x minus 3 and then square it, what would that be? Which way will it shift? It will shift to the right 3. So you'll have 2 jobs. The first thing you'll do is say, what kind of function is this? Is it squaring? Is it absolute value? Is it square root? Is it cubing? After that, then you'll say, now what kind of transformation takes place? Does it shift up, down, left, or right? Your problems are all going to be multiple choice. That makes them pretty easy, but we're almost going to pretend they're not. It would be really, really good if you had these printed, and if not, it may be difficult to see because I cannot project each one of them large enough. All right, the first one asks you to graph f of x is x squared minus 9. All right, tell me what the shape of the graph will be. It will be, it's x squared, so it will be the u. So that's the first thing in your mind you have to identify. The next thing, there is a subtracted 9. Is that inside or is it outside? It's outside, so which way is it going to shift? Down 9. I am looking for a u that has been shifted down 9 units. It's going to be choice A. If I look at B, well, it's a V. That can't even possibly be right. C, that's a V. That's absolute value. That can't be right. D is a U, which is called a parabola, by the way, but it's opening downward, and ours don't. The correct answer is A. And it has been shifted down 9 units. When you're doing this in Math Lab, they're not going to have one that's shifted 9 and one that's shifted 8, and you have to count blocks. That's not going to happen. Okay, it's not going to be picky like that. All right, let's go. You will have quite a few of these, but you see there's no calculation. There's no computation. Number 8. It asks you to graph, and it changes to h. h of x is the absolute value of x plus a 1. First thing, what is the shape of an absolute value function? It's a V shape. What does a plus 1 on the outside tell you to do? Go up 1 block. So I am looking for a V that is shifted up 1 block. So as you look at all of these, which one is correct? Do y'all agree it's A? D would be x squared plus 1, not absolute value of x plus 1. And these other two have been flipped over. All right, let's look at 9. It asks us to graph f of x is equal to the square root of x plus 3. Now, this one is a little bit premature. As a matter of fact, I'd like to skip ahead. I'm going to do that one. I want to skip ahead to number 10. And it says h of x is the square root of x minus a 6. And then I'm going to go back and do 9. What does a square root function look like? It looks like that little branch. Okay. I am subtracting 6. Now, is it inside the radical or is it outside the radical? It's outside, which means how will it shift? Down 6. Okay, so I am looking for a little branch that shifted down 6. Which is the correct choice? Okay, I'm not sure if it always goes to the right. There are conditions under which it might go to the other way, but look at it up here. It's going to the right, and all I did was shift it down 6 units. It's still going to go to the right. Now, back up to 9. Does everybody agree that this is, again, the little branch? There is a plus 3. Now, this time, is it inside or outside? It's inside. It's under the radical. It would be inside parentheses if it were a different kind of function, but it's inside. When it's inside, it always means a horizontal shift opposite of what the sign says. So which way will it go? To the left, 3. I'm looking for a branch that goes to the left, that has been shifted to the left 3, but it's still headed to the right. It will be choice C. Yes, it is this exact picture. Pick it up and move it 1, 2, 3 units to the left, and that's what it looks like. Now, if you were to look at these, I think these are in scales of 1. There are some of the graphs that are in scales of 2 or 4 or something like that. Okay. Let's go to 10. Oh, 11. Sorry, 11. I am needing to find f of x is equal to the absolute value of x plus a 10. What is the shape of absolute value? A V. What does adding a 10 on the outside do to it? It shifts it up 10. Because remember, on the vertical, it goes exactly the way the sign says. On the horizontal, it goes the opposite. So, would you tell me which one of these is a V that has been shifted up 10? Choice A. Now, starting about right here, what they do is they give you all the right shape, but they shift it every different direction. Choice A was up, choice B was down, C was right, D was left. And so you had to know which way it was going. All right. Number 12. Whoops. It is f of x is the square root of x plus a 2. What does the square root function look like? The branch. What does this transformation tell you to do? It's outside. Outside is always up and down. So it will go up 2. Take this little branch and pull it up 2 units. Which is the right choice?
B.
Choice B, as in boy. Choice A went to the right. Choice C went to the left. Choice D went down. This is the only one that went up. And by the way, if somebody is looking at it saying, well, it only went up 1 block, it's in scale of 2 blocks because this is 10. They will not try to trick you with the number. All right, 13. Which of these graphs is f of x is equal to absolute value x minus 1? Close absolute value. Well, what does absolute value look like? It looks like a V. And I've got mine sort of in, I'll redraw that. That was bad. A little better. All right. Is the minus 1 inside or outside? It's inside, which means it affects it horizontally, opposite direction. So which way will it go? To the right 1. So please look at those and tell me which V, and they are counting by 2s, which one goes to the right. It's difficult for y'all to see from the back of the room. A goes up, B goes down, C went right. It is choice C. And you might have a chance to blow these up larger. I am just not sure. Yes.
13 here.
Uh-huh.
You said it was inside the absolute value?
Then it goes.
Opposite or something?
Yes, it goes horizontally, so it's going to go right or left, and it goes right is usually a positive direction. But when it has to do with transformations, When it's inside, it goes the opposite direction of what the sign tells you.
It's inside,
Yes,
negative,
only, yes.
positive, okay.
All right, next one. F of x is the square root of x plus 4. What does square root look like? Looks like the branch. Is the plus 4 inside or outside? It's inside, which means horizontal opposite. So which way will it go? To the left 4. Which of these little branches has been shifted to the left 4? It looks like choice C. Even though there are a lot more, let's do one more, and then I want to talk about that squiggle, that wiggly one that's not represented in Math Lab. This one asks you to find the graph of f of x is equal to x minus 3, close parentheses, squared. Well, we haven't done one of these in a little bit. What does the squaring function look like? It looks like the u. Is the minus 3 inside or outside? It's inside. So which way does it shift? It goes to the right 3. When the number is inside absolute value, inside parentheses, inside square root, if it's inside, it is the opposite of the sign, horizontal direction. But if it's on the outside, it's the vertical, but there's no opposite. If it's plus, it goes up, and if it's minus, it goes down. All right, there are lots more, and it's all the same. So if you have y equals f of x plus or minus, well, I better just do it, plus a constant. If you have y equals f of x minus a constant, these are both going to be horizontal shifts opposite of the sign. So if it says a positive, you'll go left, and if it says a negative, you'll go right. But if you have y equals f of x plus c, y equals f of x minus c, for both of those, you have a vertical shift and follow the sign. So plus is up and negative is down. You know, I have to apologize and go back because there is a problem that we need to, I want to look at number, well, 21 will be fine. My apologies, I forgot. What if there's more than one transformation? This says g of x is x minus 4, quantity squared, minus 3. First of all, what will be the shape? This will be a u. It's a squaring function. There are two numbers. I look inside first. What does the inside minus 4 tell you? It's going to go to the right 4. What does the outside minus 3 tell you? Down 3. So I am looking for a U-shaped graph that moves right 4 and down 3. It is choice C. If you were to look at that bottom point, it has changed from being at 0, 0 to right 4, down 3. So you could have multiple transformations. would you have any trouble if I ask you, this is a final question, to sketch y equals x cubed minus 4? The only thing that's different is what's the shape, because you don't practice this one in MATLAB. What is the x cubed? It's the wiggle, kind of wiggles like that. And what does this minus 4 tell you? It is down 4, because it wasn't inside parentheses. So the graph of it would be, it would wiggle through here instead.
Would it not be a negative 4 since it's a minus 4?
It actually did go down. I'm not sure if I said it correctly, but you go down -1, -2, -3, -4. So I just happen to know that on the test, one of the shapes that shows up, and for some reason they weren't in MATLAB, is the cubing function. So you need to recognize it as the wiggle. Okay, are transformations okay? We have one lesson left, and if you're going to follow along and have as much fun as I hope you do tomorrow, you're probably going to want to have either 2 colored pencils or 2 highlighters. And don't go out and buy some, but if you've got them, 2 different colors, and it's nice if they're colors like yellow and blue, because if you put yellow and blue together, it makes green, or if they are pink and yellow. Yellow and something would do real nicely. You don't have to have them, but it'll make the lesson a little more fun. And if you print the notes, you'll be much better off. So, I'll see you tomorrow.